There we go. So go ahead and write this down. We're going to be taking some notes, and I hope that this is very helpful for you all. So when we talk about control flow, we're referring to the way that a computer would execute various lines or steps in a program. And so we're going to be looking at two main pieces of control flow today. First, we'll examine loops. Second, we'll examine branching. Okay, another term for loops are iterations. Anytime that you repeat something over and over again, where each repetition is called an iteration. So let's jump right in with the loops, aka iteration. Now I might pause at moments, and if you feel like there's an awkward silence, that's probably because you should be writing something down. So I want you to take notes and work these out with me. That's the best way to learn. All right, so loops, aka iteration. There's two types of loops that you'll see on the AP exam. The first one is, write this down, it's a repeat until loop. So it will say repeat until, and then this guy right here will be some Boolean expression, something that evaluates to true or false. And the key with these repeat until loops is you want to iterate over and over and over again until it's true. So you only stop when the Boolean is true. So as long as it's false, you're going to keep repeating. False, 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 repeat, repeat, repeat. You're going to repeat until it's true. The second and more straightforward loop structure is just called repeat X times. So it might say repeat 5 times, repeat 10 times. It's repeat however many times it says. There's nothing to interpret there. So let's see some examples. This is what I meant when I said, so by the way, put your pencils down, just watch. When I said repeat until that's true, that sometimes confuses students. They're like, why should I go if it's false? False feels like it's saying stop. No, throw that all out the window. Think of it like this. If I wrote an algorithm for doing math homework, okay, so this is my math homework algorithm. It might look something like this. Repeat until you reach the end of the homework. And well, what are you going to repeat? You're going to copy the problem, solve for X, and check your solution. So if I'm on number 1, I'm going to check. It says repeat until you reach the end of the homework. Now remember, that's a true or false. That's a Boolean. Well, we're at number 1. Did we reach the end of the homework? Is that true or is that false? Clearly, it's false. We're at the beginning of the homework. So if that's false, we're going to do this stuff. Because why? Because we're not at the end of the homework yet. So every time I go through these numbers, all the way till number 14, this is going to say false because I'm not at the end of the homework yet. So I'm going to keep repeating the problems. And here's the key. Once you repeat the steps inside, you do not continue to the outside. You go back to the repeat line and you do that again. So on step 14, false, I haven't reached the end of the document. So I'll copy, solve, check, and then I'll go back to my first line. And now I'm on the next problem. Repeat until you reach the end of the homework. Well, there's one more problem. And then finally I reach the end. When I reach the end, this is true. You reach the end, true. So that's telling me, okay, repeat until it's true. Now I'm gonna stop. As soon as it becomes true, you just skip everything inside and go to the final, to the next line afterwards. So that's an intuitive understanding of why we're repeating until true. So let's see this in action. Okay. I have some simple code. You don't have to write anything yet. Just watch. So let's say I'm going to start with x equal to 9. That's how the problem begins. And the code says repeat until x greater than 15. Well, what are we repeating? We're repeating all of that indented section. So let's begin executing our program. And the way I'm about to show you is how I want you to start writing on your AP exam, like to trace the program. So first, see how many variables you have. We have only one variable, that's x equals 9, and we're going to initialize it. Now, I'm going to go to the next line. Let's call this line 2, 3, 4. repeat until x is greater than 15. Guys, true or false? T or F? Is x, which is 9, greater than 15? False. Okay, if it's false, remember, we're going to enter the repeat. So we're going to take x, which is 9. Remember, for these, you're going to start, when you have an equation like this, you're going to start on the right side. So plug in your 9, add it up, so that's 15, and then assign it into x. So now that 9 disappears, becomes 15. Notice how I'm keeping track of my variable on the same line. I'm not doing this. No, that's confusing to go down. So I'm teaching you a strategy. Cross out, because what's really happening in your computer is the memory is being overwritten, and then write it in the same block of memory. We want to imitate the way that our computer works. Okay, so now I'm going to do it again. Remember, we're going to keep repeating until we get true. So I'm going to check, is 15 greater than 15? Certainly not. 15 is not bigger than 15. It is itself. So we're going to, again, enter the loop. And we're going to, this time, take our x, which is 15, and add 5 to it, storing that in my new x. So this disappears, and now x is 20. Whenever you finish a repeat, go back to the repeat line. And now we're going to do it a third time. Repeat until 20 greater than 15. Is this true or is this false? 20 is greater than 15. It's true. So I stop. I skip, since this is true. And it says only repeat it until it's true. Then we're done. We're going to skip the inside and we're going to go straight to display x. And so for x equals 9, the program will display 20. That's what the program will display. The second question here says, how many times will the loop iterate? So basically saying, how many repeats did you do? Well, remember, first we set x equal to 9. And then our first iteration, x became 15. So that represents one iteration, one IT. Then it was a second iteration that made that 15. We added the 5 again. So you can ask basically, how many times did you add 5? I added 5 2 times. And so this had 2 iterations. Remember, we never did that third iteration, because on our third attempt, it said true. So it only had 2 iterations. So basically, to count the number of iterations, you can see how many times this guy changed, and there were 2 changeovers. Do not count the number of variable values. That's not the number of iterations. We only repeated twice.
Wait, wouldn't 9 plus 5 be 14?
You're right. I don't know what I'm doing. 9 plus 5 is 14.
And then
what did I do?
next one would be 19.
Thank you so much. Why did I make it 15? Okay, so 9 plus 5 is 14, and then 14 is 19. There we go. So I was off. Hopefully, besides the math errors, the process made sense, yes? Did I confuse anybody?
Yes, but now I'm wondering if this is the reason why I'm doing so poorly.
Oh my gosh. We'll be okay. We'll practice it again. Okay, let's try x equals 15 and then x equals 20. I want you guys to try it the way that I did for both, and then we'll check our answers in 40 seconds. Try both. For those of you wondering, this class will go until 6 p.m. Okay, those of you who did 15, what happened? What did the program display? All right, check your work against mine. I wrote the answers. And let's see if we can quickly walk through it. So when x equaled 15, I checked, is 15 greater than 15? That's false. So I entered the loop and I added 5 to my 15, stored that in x. So x became 20. Then I went back to my repeat. I said, is 20 greater than 15? That was true. So I skipped the inside, I stopped, and I displayed 20. So total, there was one iteration. If you got that, give me a thumbs up by typing BD, all lowercase in the chat, because notice the thumbs up looks like a B and a D if you look at my hands. Thumbs up if you got that. And then for x equals 20, well, if I started with x equals 20, then when I check, repeat until x is greater than 15, well, right away, 20 is greater than 15. My very, very first check is true. So I don't do any repetitions. This condition is already met. So I simply displayed what x was, which was 20, and I iterated 0 times. How many of you guys got that? Give me a thumbs up in the chat. Excellent. Let's do another example. So here the idea is if false, you're going to enter and do the inside stuff, and then always go back to the repeat line. If it's true, you skip the loop entirely and you move on to the next line. Okay, this time let's do it with 2 different examples. Yeah, do x equals 10 and 16. Another 30-second problem. This is for you to test yourself. So try it. These are the same thing. So once x is 10, the other time x is 16. It's the same code on both sides. Look down and look up only to check your work. All right, check your first one. If you got 20, you got it right. Let's do the second one together. If x is 16, I'm going to check. Is 16 greater than 15? Yes or no? True or false? True. So Tiffany, what do I do? Do I add 5 or do I skip? Excellent. Since this evaluated to true right away, remember when you get true, you're going to skip the loop and immediately display x. So what is it that gets displayed? 16. There were 0 iterations there because that condition was already true. Hopefully that made sense for you. Feel free to stop me if you have any questions. All right, let's practice another problem. This time I've changed things a little bit. It's just the condition that's different. It says repeat until x equals 10. Before it said repeat until x is greater than. So now I have an equal sign. So let's check the first one together, x equals 0. By the way, feel free to unmute and just call out your answers. So if x is 0, and I'm going to repeat until x equals 10, is 0 equal to 10? That's what I'm asking myself. False. And if it's false, I'm going to keep repeating until that's true. So we're going to go ahead and enter the loop. And my x becomes 5 now. I don't want to do it there. Keep track of your variables off to the side. So x became 5. Then we go back to the repeat. Is 5 equal to 10? False. So I'm going to enter the loop again, add 5 to it. That's 10. You always want to go back to the repeat. Finally, is 10 equal to 10? Ding, ding, ding. We have a winner. We wanted to repeat until x was 10, and it is 10 equals to 10. So we're going to skip the inside. Our final answer is 10. Did you follow? I hope. If you did, do x equals 1. Tell me, what will you see at the end, and how many times will the loop iterate? So I want you to answer both questions. Don't forget to trace your variable on the side by writing x equals. This time we're starting with 1. And don't type your answer until I say go. take 10 more seconds and then type into the chat, what will your program display and how many times will it iterate? 9, 8, 3, 2, 1, go. Let's see what we got. So let's see. Some people are saying 10 times. Some people are saying it doesn't work. Some people are saying infinity. Let's see what happens when x equals 1. So we've done the first line by initializing our variable. We're going to repeat until x equals 10. Well, 1 equals 10, that's false. And we want to keep repeating until true. Repeat until it's true. So we're going to enter. So 1 plus 5 gives us 6. Great. And remember, once you enter, you have to go back to the repeat loop. You never stop repeating until you get true. Next, we check, is 6 equal to 10? Because that's what my x is now. And again, that's false. So I'll enter the loop again and add 5 to my 6, storing that in x. X is now 11. Now I go back to the repeat. Always you go back to the repeat. Let's check, is 11 equal to 10? That's false. So I'm going to enter my loop again. X is now 16. What's the problem here? Who wants to just come off of mute and tell us what's the problem?
X will never be equal to 10.
X will never, ever equal 10, you guys. It's the next number it's going to be is 21. The next number is going to be is 26. It's just going to keep adding 5 forever. This is an infinite loop. And the reason it's an infinite loop is because this condition can never be satisfied based on what we started with, which was 1, and then adding 5, we missed 10, right? We go 1, 6, 11. We skipped over the 10. So x will never equal 10. And if the condition is never true, then you have an infinite loop that never ends. And eventually will cause your program to crash and you'll have to probably restart your program, right? Or your computer. So trick question, the program will probably display an error because it's never going to finish, and the loop will iterate infinite number of times. Hopefully that made sense. So why don't you guys try this next problem? I'll put 1 minute on the clock and then we'll review our answers. For the sake of time, don't try and write down the code. Just on your paper, keep track of the variables. So notice this time we have 2 variables that we're initializing. So you're going to keep track of 2 variables, each on its own line. And remember, as you update, you cross out, you write the new number. You cross out, you write the new number. All right, 1 minute on the clock.
What's the initial value of x? Oh, never mind.
0 and 0. James, you made a mistake. I want you to go very carefully line by line. Don't rush. You want to do this real slow. Take another 15 seconds. 5, 4, 3, 2, 1. Let's see our answers. Anybody? 9 and 3 look good to me. Let's see. X is 0, y is 0. Repeat until x is greater than or equal to 7. 0 greater than or equal to 7, that's false. So we're going to add 3 to x and add 1 to y. And then we go back to our repeat. Now we're just comparing the x. So is 3 greater than or equal to 7? That's false. So again, we enter our loop. We add 3 to x, we add 1 to y, and we repeat again. This time, my x value is 6. Is 6 greater than or equal to 7? False. So I add 3 again, add 1 again. And then on this time, my x is 9, and 9 is greater than or equal to 7. It's true, so we skip, and we're going to display 9 and then 1 because it says display x and y. So if you got 9 and 1, that is correct. Did I say 1? What am I talking about? And 3 and 3. You can just blame it, you guys, you can just blame it on the pandemic. All right. Here we go. Let's move on. Let's do this last one and then we'll do an AP question. 1 minute on the clock. Wait, let me just double check. Yeah, 1 minute on the clock. All right, 10 more seconds. 5, 4, 3, 2, 1, hit enter. Let's check. So I'm gonna repeat till x equals 12. I'm gonna add 5 to my x and 1 to my y. So that becomes 8 and that becomes 1. Checking again, 8 is not equal to 12. So we're going to, that's false. So we're gonna repeat, add 5 to x, add 1 to y. Then you're gonna check again, is 13 equal to 12? It's not, and it never will be, right? X never will be 12. Please tell me I didn't make a mistake. No, I think we're good. So what's the result? Nothing. This is an infinite loop. Did you find your error? Those of you who made an error, were you able to figure it out? Yeah, you have to be really careful. The equal sign, less than, greater than, easy to mess up if you're rushing, but just be careful that you're reading that condition right. Even I was making like adding mistakes a second ago. All right, let's do our first AP question, you guys. I'm so excited. Ready? The way that this will work is I'll put a minute on the clock. You already know the drill. Don't hit enter until I say go. Five more seconds, and then you're gonna type your letter A, B, C, or D into the chat in 5, 2, 1, go. All right, we're seeing a whole lot of A's. Welcome, Joseph. Good to see you. All right, it says, which of the following replacements for missing condition will result in an infinite loop? Let's see why A was such a popular answer. So if J equals 6 was the missing condition and J starts at 1, we're going to repeat until J is 6. And what are we doing inside the loop? Logically, we're adding 2 to J. So without really even needing to trace the program, we can just kind of logic our way through this. It says add 2 to J and then store that in J. So we're just going to keep updating J by 2. So it becomes 3, 5, 7, 9. Notice it will never equal 6. We jumped over 6. We went from 5 to 7. And so indeed, A is our correct answer. It will result in an infinite loop. B will actually stop our program, won't it? As soon as we reach the number 7, 7 is greater than or equal to 6, so our program stops. Same with J equals 7 and J greater than 7. Those will also be stopping points. So A was our answer. All right, this one's a little bit tricky, but again, I encourage you to take the route of trying to logically understand what's going on here instead of actually running the program. If the logic doesn't work out, you can always actually write like I equals 1 and run the program. That's always an option, but try to do it just by logically thinking first. 1 minute's on the clock. 30 more seconds. Ten more seconds. Go ahead and submit your answer in 5, 4, 3, 2, 1, go. B, A, D, B, 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 C, D. Wow, we're all over the place. All right. So let's look at the ways we could have done this problem. The first way we're going to call brute force attack. And that's the way of just doing, just going for it, plugging it in. So let's see, I is equal to 1. And I'm going to repeat until I is greater than 10. Now, before I do it, I want to see if I can figure out what's going to happen just by looking on the inside. Look at what's different. Everything is the same. These are the same. These are the same. What's different? Here, we're going to display I first, and then we're going to add 1 to it. But on the right side, we're going to add 1 to it and then display I first. So I'm going to try and pay close attention to that difference to see what's going to happen. But let's run the program on the left first. So is I greater than 10? No, so I will display I. By the way, you want to keep like a display box separate from your variable tracking. So why don't we do this box for our display? So it's going to display I, which is currently 1, and then it's going to add 1 to I and update it. So it becomes 2. Then it's going to repeat, and it's going to keep going until I is greater than 10. So the next thing it's going to display is I, which will say 2. Then it's going to add 1 to it. Then it's going to display that, which is 3, dot, dot, dot. Let's go to the right. I equals 1. We're going to do the same check. Is 1 greater than 10? No. So we repeat until it's true. Let's enter the block. And so so 1 gets added to I, so I becomes 2, and then we display that value. So the first number that's displayed here is 2, whereas the first number that's displayed here is 1. Interesting. So we definitely know they're not displaying identical values. Okay, A is out. And we also know that they're not going to display the same values in different orders because this is going to keep adding 1 to I. So it's going to become like 3, and then 3 will get displayed, then 4 will get displayed, right? So it's not the same values because this guy will never display a 1. It will never get a 1. So B is out. Now C says they will display the same number of values. Okay, let's try and think through this. How many times will this iterate? Well, it's going to keep going until I is greater than 10. So it's going to display when I is 4 and 5 and 6 and 7 and 8 and 9. What about 10? Is 10 greater than 10? No. So we're going to display it. It's going to display 10. And then it's going to make I 11. And then it will say, is 11 greater than 10? No. So it's going to stop. So it's going to display 10 numbers, 1 through 10. Moving to the right side, it's going to display 5 and 6 and 7 and 8 and 9 and 10 even, because 10 is not greater than 10. Okay, but on that last iteration, this 10 right here, I add 1, so it's going to display 11. No, sorry. So we're right now where x equals 10 and we're checking, okay? Is 10 greater than 10? No, it's not. So in order, it's going to add 1 to our I. It's going to make it 11, and then it will display that I. So it's going to display 11. So what's happening? This one shows the numbers 1 through 10. This one shows the numbers 2 through 11. So it's going to display the same number of values, but the values will differ. The same number of values. They're both going to display 10 values. Okay, that is one of the harder problems. But you can reason through it and recall that what I immediately paid attention to was what's different. So the order of displaying first, then updating, versus updating first, then displaying, that made a difference in terms of what was displayed. Try this one. 1 minute. This time you're going to keep track again of how many variables do you see? How many variables are we initializing? If you said 2, that's correct. So keep track of I and sum, and you have 1 minute to answer the question. Ten more seconds. Go ahead and submit your answer in 5, 4, 3, 2, 1. Is anybody done? I'm seeing a lot of D's. Let's see what happens. Repeat till I is 4. And what are we going to do? Okay, numerous things. First, we're going to, okay, this is interesting. It's not updating I, it's just taking the value of 1 and making that my I. So I is now 1. Then we're going to add I and sum. So right now I is 1, sum is 0. So we're going to add 1 plus 0 and put that in sum. Well, 1 plus 0 is 1. So there we go. It's 1 now. And then we're going to add 1 to our current I, which is 1. And so I becomes 1 plus 1, which is 2. Wow, that was a lot. All right, next. We're going to go again to the repeat until I equals 4. Well, I is 2. So we're going to enter the repeat because that's false. And we're going to, again, set I equal to 1. So again, notice we're hard coding what I is each time. We're not updating it. We're just setting it to 1. And then we're going to add I plus sum. Well, I is 1 and sum is 1. We're going to add them together. 1 plus 1 is 2. And I'm going to store them in sum. So sum takes on the value 2 now. And then we're going to add 1 to our I. Well, I is 1. So 1 plus 1 is 2. And that's my new I value. Are you guys seeing a pattern here? The answer is D. Nothing is displayed. This program runs infinitely. Why? Who can tell me why? Come off of mute. Why does this program run infinitely?
I will never equal 4.
I will never equal 4. It keeps getting passed down between being 1 and then being 1 more than 1, which is 2, and then it becomes 1, and then it becomes 2, and 1, 2, 1, 2. So it's never going to equal 4. D is the correct answer. All right. Let's look at one of my favorite classes of questions called the robot questions. All right. It says, the following questions use a robot in a grid of squares. This guy right here, this is your robot. The robot is represented as a triangle, which is initially in the bottom left square of the grid and facing right. So notice that its pointy side is the direction it's facing. Okay, this is like a standard style of question. Consider the code segment below, which moves the robot in the grid. So what's happening? It's setting some variable n to 3. What's the first thing you should do when you see a variable be initialized in any question? What is the first thing you should do?
Write it down.
Write it down. Keep track. You're going to trace the program. So it's setting n to 3, and then it will repeat 3 times all of this. Okay, it's going to do this whole thing 3 times. So let's begin. First, it will repeat n times, and so n is 3, plug it in, and it's going to move forward. So this move forward is going to be repeated 3 times. Let's do it. Show it on your paper. Move forward, move forward, move forward. So now it's here. And watch what I'll do. If you're taking a paper and pencil test, you can write directly on the test, actually draw this. If you're taking the test on your computer, then you can try tracing it and keep track of the robot like that. So we've moved forward 3 times. Now we can rotate left. So if this robot is facing this way and it rotates left, facing the direction left, that means it's going to go up now. Okay, so now it's facing up. And then we're going to take 1 away from n. So it's facing up now, and then n minus 1. So 3 minus 1 is 2, and that becomes my new n. Okay, let me slow down for just a second. What the hell just happened? Are we done? Let me ask you that. Are we done? Or are we just getting started? Because right now I'm channeling this energy of like being lost in the middle of an exam. I just did a bunch of stuff and I forgot what I'm doing. Who can tell me what's my next step and why? We're not done. What's the next step? Yeah, Zaria, we have to repeat that 2 more times. Remember, we did this guy. We just did this once, but it says do it 3 times. So we got 2 more times on it. Okay, so next time we're in, we're gonna repeat n times. Remember, n is a variable. And what is n now? N is 2. So this time we're going to move forward 2 times. 1, 2. Draw it. What happens next? You can just jump off of mute, you guys. What happens next?
Rotate left.
Rotate left. Okay, so facing that way, turning left. Imagine like you actually do it. You'd end up facing this way now. And then we move to our last line. N minus 1 becomes n. So n is currently 2. 2 minus 1 is 1, and that gets stored in my n value. N is 1 now. Are we done? Nope.
No.
Got our 3rd try. So why don't you finish the program and then pick your answer? Take 10 seconds or so. You need to run this on the last try now. It's your 3rd run. Be careful. Final answer in the chat in 5, 4, 3, 2, 1. Okay. Let's see. This time we're going to repeat just 1 time because n is 1 now. We're going to move forward so we end up in this box. And then we have to rotate left so we end up facing down. And then n gets subtracted and n is now 0, but that doesn't matter. Our answer was A. That is how you do the robot problems. Just trace it out, follow these steps. You're going to see a lot of them. Shall we do another? All right, take this one. I would say this is a medium hard. So any way that you need to get through it works. You have 90 seconds. Okay, I'm just speaking to Tiffany right now. The repeat on the last one, it said repeat. Are you talking about the repeat 3 times or the repeat n times?
I'm talking about where it says repeat 3 times.
Yeah, so we did that. We went through that entire segment 3 times. The first time we moved forward 3 times. The second time we moved forward 2 times. And then the third time we moved forward 1 time because n kept changing at the end. Do you remember that?
Yeah, but what about the one that actually said repeat 3 times instead of repeat n times?
We did not. Okay, hold on.
Oh, okay.
Are you sure it clicked?
What?
I said, did it click?
Yeah. Okay. Thank you.
You're welcome. All right, go ahead and enter your answers now, if you're ready. Take your time, keep going. Okay, are there any answers out there? Let's dive into the problem. So first we're going to keep, we have two variables, so we're going to write them on two separate lines. Count is 1, sum is 0, and we're going to repeat this 10 times. So the first thing we're going to do is add sum and count together. So what I'll just do is I'll just do that in my head, okay? So I'm going to add those together, 1, and then that becomes my new sum. I store it in sum. Remember, we take this guy and we store it on the left. So sum is now 1. And count gets 2 more added to it, so count becomes 3. Cool, and that's 1 repeat. We're gonna do that 9 more times. So sum and count get added, so that's 4, and it goes into sum. Count gets 2 more, and that's our second repeat. Okay, a few more times. So sum and count get added. Whoops. Sum and count get added. So notice I'm going faster now because I see the pattern. And then count gets 2 more. Sum and count get added, becomes my new sum. And then count gets 2 more. Sum and count get added. And I could keep going, right? I could keep going. But let's see if we can find a pattern. And then count gets 2 more. If I'm going to repeat this 10 times, first of all, what is it even displaying? It's displaying sum. So the only thing it's going to show me are these guys right here. First of all, did I do my addition properly? I think so. Okay. So I'm seeing some people say D. The program displays the sum of the odd integers from 1 to 19. So let's see. The first time for sum, I added 1, which was an odd integer. The second time I added 3. The third time I added 5. Remember, we kept adding it to whatever count was. We added count to our sum. And yeah, count was always an odd number, wasn't it? Because it started as 1 and we kept adding 2 to it. So it went 1, 3, 5, 7, 9. Interesting. So the pattern emerges. The program displays the sum of odd numbers from 1 to 19. So let's see. Would it have gone all the way to 19? So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Is that 10 times? 1, 2, 3, 4, 5, 6. And then over here to 7, 8, 9. And then it would go to 21, wouldn't it? I'm confused. Anyway, the answer was D. Sorry about that, you guys. The answer was D. That was a really tough one. Okay, but the point is that you're seeing that you can start by brute force going through the program, but hopefully you'll find a pattern eventually. Okay, this one looks scary, but it's really not. Let's read it together. The procedure draw a circle, X, Y, R. So these are the parameters that it takes. Can be used to draw a circle on a coordinate grid. The circle is centered at X, Y, and it has a radius of R units. So we've got the center and then the radius. The procedure will be used to draw the following figure on a coordinate grid. Which of the following code segments can be used to draw this figure? All right, what the hell's happening here? Let's look at A. We'll do A together. So A is setting our X to be 3, our Y to be 6, and then it's repeating this 3 times. What's happening? Well, it's going to draw the circle. First, it will draw the circle at our X position. Okay. First, it will draw a circle at our X and Y with, remember, this was an R, so that was our radius of 2. So it's at 3, 6, which is right here. 3 on the X-axis, 6 on the Y, and then it has a radius of 2. So yeah, so we get our first circle. So far, so good. We did this line. Next, we're going to add 2 to our X and then add 2 to our Y. So we did that and that. And remember, it says repeat 3 times. So we'll do it 2 more. First, we're going to draw the new circle with our 5, 8 as our point, and then a radius of 2. So clearly we're off. Clearly we're off. A is not the correct answer. It's moving in the wrong direction. And so that is how you'll approach B now. Go ahead and see if B works, yes or no. If yes, put a Y. If no, put an N. Yes, no. You guys are saying it works? You sure about that? Let's see. So X is 3, Y is 6. Okay, so we know that. And then we're going to repeat it 3 times. I'm going to draw this circle. So at 3, 6, that's this guy with the radius of 2. And then we'll add 2 to our X, so it becomes 5, and minus 2 from the Y. So the next circle that we draw on our second repeat will be at 5, 4. Let's see, 5, 4 takes us here. Aha, it worked. So it'll do it another time. It'll add 2 to the X, subtract 2 until it goes to 7, 2, and it draws the final circle. Now, looking at this, who can tell me like an easier way, a faster way, a logical way to figure out that B is the answer and A is not? How could you have figured out B was correct without actually writing all the numbers down? Anybody? Logically. So yeah, I'm getting some answers in the chat. -2, so it's moving in the negative direction. Yeah, so there is something here happening with the X. The X is getting added to. And remember, if you're adding to our X, your X is getting bigger, you're going to move to the right. So this is saying move 2 units right. But when we minus 2 from our Y, remember Y goes up and down. So if I'm minusing 2 from my Y value, I'm going to go down. So this is saying move down. And indeed, if we start at our first circle, we do want to move 2 units to the right and 2 units down for our next, and then 2 units right and 2 units down for our next. Cool. So that would be like another approach to doing the problem. Okay, let's move on. All right, last skill of the day. Thumbs up if you're feeling okay, if you're feeling good, you're ready. If not, ask me a question. You can leave in 5 minutes. All right, looks like we're good, no questions. All right, let's do our last skill, which is if-else structures. So branching, also known as if-else structures, go like this, or selection, it's also called selection. So let's look at an example of what an if-else is versus just an if. What's the big deal? Well, let's start with x equals 50 and run program 1, and then we'll run it with program 2. If I say x is 50 and I run this program, what will get displayed? Well, we're going to check if x is greater than 50. So that's our Boolean. It's going to be true or false. Right now, is this true or false? 50 greater than or equal to 60. It's false. And if it's a false statement, you will skip the next line. So it's not going to display anything. The program ends without ever executing anything. So this would be like an empty program. There's nothing on the screen, okay? It checks 50, it says display X if you're greater than or equal to 60, and we weren't. It was false. So nothing happened. Let's go to the right side. Now if X is equal to 50, I'm going to check. If 50 is greater than or equal to 60, pause. Ask yourself, is that true or false? Again, it's false. So we're going to skip the line, but we have this else option here. And what the else says is, hey, if your first condition was false, do this instead. This is your else. The thing you're going to do instead, you're simply going to display fail. So if I run x equals 50 through program 2, instead of just not showing anything at all, it will show the alternate display, which is fail. And that's what our else statement does. So the key thing to know is if this is false, we go to our else statement. If this is true, if that's true, then we will run whatever's inside our if, and we will not look at the else. It's one or the other. It's either the if or the else. You can't do both at the same time. So if x was equal to 70, let's see what would happen. 70 greater than or equal to 60, that's true. So I would display x, it would display 70, and I would not do anything else because it's one or the other. You can only do, think of it like this. These are different branches. You can only go one or two ways. You can't display x and display fail, one or the other. Here's another way to visualize the one or the other if else branch. It just looks a little more complicated, but the AP exam might have it in this format where they add squiggly parentheses. It's the same thing. If this is true, display that. If it's not true, display that. So let's see if we can learn some hacks for this. When you see if-else structures, they might become increasingly complex. And so here's what I'd like you to do. Every time you see an else, I want you to connect it to an if, the if right above it. So like that. Now each connection represents, so we have two options here. You can do be A or it could display B. But what's the maximum number of things this program could display? It could display a maximum of one option because it would either be A or B. So each one of these little connections that you make represents a mutually exclusive. You got to pick one or the other. Okay? Let's look at the second example. If A, if B. Since this is an if and this is an if, there's no connection between them. So you could actually do A and you could do B if those things evaluate to true. So if this is true, you do A, and if the second thing is true, you do B. So here you have two options, and you can display a maximum of two options. You can actually get both. So there is no connection to draw. Let's look at the next example. We have an else, and so we're going to connect it to the closest if. So we can only do one of these. You guys tell me, how many options in total do we have? How many possible different things could we see? 1, 2, or 3? Well, we have 3 options, right? It might be A that we see, it might be B that we see, or it might be C. So there's 3 different options. But what is the maximum number of options that will happen? Or what is the maximum number of lines that will run? So here we have 3 options. The maximum number of lines we could run is 2. The first one will run if A is true, all by itself. And then between these two, only one of them will run. If B is true, we'll see B, but not C. And if B is false, then we'll see C, but not B. Does that make sense? So we have 2 maximum options that we can see at any given time. You guys try the next one. Tell me, how many options do we have? How many possible outputs could we see? How many options are there? That's an option. That's an option. That's an option. That's an option. We have 4 options. Okay, now think carefully. What is the maximum number of lines that would get executed? What is the maximum number of options that could happen? It's 2. 2 is correct. So anytime you see an else, link it to the closest if above it. So one of these 2, only one of those 2 could happen. And then between the next if else, then only one of those 2 could happen. So we have 2 maximum options that could run at any time, because it's either going to be A or B, and then it's going to be C or D. We can't have A and B and C, that's too many. Okay, let's look at the next one. So this is the first time that we're seeing an else that doesn't have a statement right after it. It's an empty else. So this, for these, this is linked. This else if, it's like a branch of its own. This else is linked with that if. They're going to run together. Okay, now remember, this else, we also going to connect it to the if right above it. So only one of these two options could run. And then this else is linked with the if right above it, and only one of those two options can run. Go ahead and think through this. What's the maximum number of options? Sorry. What's the total number of options? And then what's the maximum that could run at any time? So we're saying if A is true, then do it. Else, if B is true, do it. Else, if C. Charlie's got it down. So we have 3 total options, A, B, or C. But the maximum that could run at any time, let's see. If A is true, then I'll run it. And since the next thing says else, none of that would happen. So only A would show. Okay, now let's pretend that A is false, okay? If A, so if that's false, then I'm gonna go to the else. But remember, this else is part of this else if. So now it's between B and C. If B is true, B will run, or C will run. In this case, only one option will happen. So here's what this is saying. If A is true, do that. Else, you can try B. Else, if that doesn't work, you have a third option, which is C. So you can only take one path. You can only take one path. So it's either between B and C, but it's either between B and A, only one of them at a time. Let's look at an example that will make this less weird. Okay, so we're running over. If you have another lesson to go to, please go. We're gonna run a little over, like 10 more minutes. Okay, so let's see what happens if we run x equals to 50 in one of these that looks like an AP exam question. So I'm gonna start x equals 50, and we're gonna see what happens. First, let's say that this is score equals 50, okay? So 50 is less than 60, so that's true, and so it's gonna display failing. And since this else is connected to that if, nothing else can happen because we've already taken one of the 2 tracks. The only time we will ever get to this else is if this is false. That's the only time we would ever even look at that branch. Okay, so if the score was 50, it would simply say failing, and then we're done. Now let's see if the score was 60. So is 60 less than 60? True or false? False. So it's going to skip this line and go to the else statement. But this else is connected with that if, so they're the same. And then this else here is connected with that if, so we can only do one or the other. So check it out. So score is 60. Is 60 less than 80? That's true. So it's going to display passing, and it will not look at the else statement. So if else, it's one or the other. So for 60, it's just going to say passing. Try it with 72 now. What's going to happen with 72? So link these, and this else if is the same. And so what will display? If 72 is less than 60, that's false. So I'm going to go to the else. Is 72 less than 80? That's true. So it's going to say passing. Okay, excellent. You try with 92.
It's 6:06.
I heard, yeah, I know. We're going to go 4 more minutes if people can stay. I'm recording this for my students. But you're okay. You can leave. I won't take it personally. Okay, try this. I do want to end with an AP exam question. Try 92. Okay, you can just jump off of mute if you have an idea what's going to happen.
Excellent job.
Go ahead.
The score is greater than or equal to 90, and then it'll display excellent job.
So it's going to display first the score, right? It's going to display 92.
Oh, right,
It's greater than or equal to 70. That's true. So it'll do this. But this if is not connected with any else. So it can move on and now check the next if, totally separate. And now it's going to say, is 92 greater than or equal to 90? Yes. So it's going to display excellent job. Okay. And it's going to skip, these two are connected. Since it went with excellent job, it skips the else and we're good. Okay. But there's something kind of weird about this program. Try 75. Try 75. You'll see why this program is a little buggy. X is 75. So what happens? First, if that's true, it will display the score. 75 is greater than 70, so it will display 75, the score. And then it will jump to the next if. If the score is greater than or equal to 90, guys, is the score greater than or equal to 90?
No,
So what's it going to show?
failing.
It will show failing. It's going to check if the score is greater than 90, since it's false, and there's an else, it will automatically go to the else. Now, is 75 a failing score? Certainly it's not. So what's the problem here? How could I make one tiny adjustment? I want you to think, okay? How could I make a small adjustment so that this only says failing if, sorry, how can I make it so that this only says failing if it's under 70? What change
Make
could
an
I
if statement.
go ahead?
Make an if statement that says score is less than 70.
Without typing anything new. I just need,
Oh,
yeah, without typing anything new. Let's see. So check this out. Look at the change that I made. I moved this if a little bit, and I moved the display. So I took them from being separate instances right here to pushing them inside of the first if. So now I will only say excellent job if, first of all, they got greater than 70, and then if they got greater than or equal to 90. So those two things lead up to each other. This is what we call a nested branch. So in order to get to excellent job, first I have to get inside here by this being true. And then I would have to get inside here by this being true. And the only time it will say failing is now I've connected this else with this if branch. So if this is false, it will automatically show failing. So now if I get a score like 75, it won't say it's failing because it either was true or it either displayed my score or it said failing. So let me run it one more time so you guys can see. So if X is 75, we want to check. Is 75 greater than 70? True. So I'm going to enter all this indent. I'll display the score, and then I have another statement to check. Is the score greater than or equal to 90? No. So I won't run this program. So I won't run that program, and I'm done. I will never even reach this else because it's either this branch or this branch, since those two guys are connected. This else would be connected with the closest if that's in alignment. So that works better. Okay. Let's do a AP question and we'll end here. All right, number 15, real release question. Type it into the chat. You have 60 seconds. All right. Type your answer in 5, 4, 3, 2, 1, go. All right, we're getting a few answers. Let's check. So first I'm going to try linking all my if else's, my else ifs, because I know that those together are like the same branch. They're going to be one read together as one line. I'm going to link all my else's with the nearest if that is above it so that I know I can only do one or the other. So I can either do November or Yankee. Notice that since these are the same, this else is also paired with that if, so I can either do hotel or I can go into the other branch. Okay, so these are all the links that I'm making. Well, let's see what happens. If X is 5 and Y is 10, I'm going to check. Is X less than 0? No, 5 is not less than 0. That's false. So I immediately jump to my next else and I check else if. Is 5, that's X, greater than Y, which is 10. Again, that's false. So I'm going to not do that line and I'm going to automatically skip to the next check. If Y is greater than 0, so is 10 greater than 0, that is true. And if it's true, you'll do the line after. And if there's an else connected, you skip that. It's one or the other. And so November was the answer. Good job, good job, good job, good job, good job. November. Hopefully that is helping you. This is a good one. Okay, let's see this. 1 minute. Think through this. It says, consider the code segment below. Which of the following changes will not affect the results when the code segment is executed? And you have 4 options to change. They want which one will not affect the results. Ten more seconds. 5, 4, 3, 2, 1. Do we have any answers? A is correct. A is correct. So let's think through this. First, it has an if else setup. Very simple one. If A is 0, we're going to add 10 to A and create B. That will be our new B, whatever A plus 10 is. And if A is not 0, if it's 1 or 2 or negative a million, then we're going to add 20 to that number, and that will be our new B. That's it. There's just 2 options. So A is correct. Why? It says change line 3 to B gets 10. Who wants to explain why that is our correct answer, would not change anything?
Because 0 plus 10 is just 10.
Yeah, Charlie. Yes, that's correct. So notice that if A is 0, then I add 10 to A. So the only time this will ever happen is if A equals 0. So A is always going to be 0 when that line gets executed, right? That's the only condition where you can go to line 3. So 0 plus 10 will always be what B is assigned. Therefore, if we just say, hey, set B to 10, we're good. B is wrong because it's just totally out there. Like they're changing A instead of B, so the wrong variable gets updated. Change line 7 to B gets 20. That's not going to be good because remember, A could be anything. It could be 1 or 2 or 5, so we don't know what B will be. Therefore, we can't just say it gets 20, and then D was just a distractor. Okay, we're going to do another one because I have no regard for time, but of course, if you want to leave, you can leave. There's no problem with that. Let's do a grid problem. So it says 2 grids are shown. Each grid contains a robot represented as a triangle. Both robots are initially facing left. each robot can move into a white or gray square, but it cannot move into a black region. Let's end on this one. For each grid, the program below is intended to move the robot to the gray square. So that's where you want to end up. Okay, the program uses the procedure goal reached, which is right here, which evaluates the true if the robot's in the gray square, otherwise it's false. For which of the grids does the program correctly move the robot to the gray square? Let's end on this. So which grid does this program correctly move our robot to the gray square? 60 seconds on the clock. All right, I'm accepting any answers, and then we'll talk through it. Okay. I honestly don't know what the answer is, but let's figure it out and see if we got it. So first, I'm noticing that I have this if else connected, and I can only either do the if branch here or this branch since they share that else. Okay, so I'm either going to be rotating right or rotating left, not both. And then once I check if I can move right, rotate right, or if I can move left, rotate left, then once I've checked my rotation, then I see if I can move forward, then I move forward. So what I'm getting from this is check right, then check left, then move forward. Okay, let's see grid 1. So it says, if I can move right, rotate right. Well, this guy's currently facing this way, so right for him would be over there. It can't go into a black box, so it can't move right. This is false. It cannot move right. So it's going to skip, and it's going to now check if I can move left. Left is that way. It can't go that way, so it's not going to do anything. It's not going to rotate left. There's no more else's, so nothing needs to happen here. Okay, neither of those happen. Now we're going to move forward because yes, I can move forward. And it says repeat until the goal is reached. So we're just going to keep repeating this whole thing. So let's check. Can I move right? No. Can I move left? No. So I'm going to move forward. Next repeat of the loop. Okay, it says if I can move right, I can move right. So what will I do? I will rotate right. So it's going to face this way. And since this is an else, we do not even pay attention to anything there. And now we say if I can move forward, move forward. Great, now it's gonna check right, no, left, no, so it's gonna move forward. Now it's gonna check right, yeah, it can, so it will rotate. And remember, it won't go left also, it's one or the other, and then it will move forward. And then it can't go left, can't go right, it will move forward. Now it's gonna check, can it go right? No. Can it go left? Yes. So it will rotate and then move forward, rotate, then move forward, and then right, no, left, yes. Yes, this gets us to the end. Long story short. So grid 1 definitely works. Does grid 2 work? Yes or no? What do we think? Charlie says no. Okay, Charlie, tell me why.
So once you get to the top, like, yeah, keep going. I'll tell you when to stop.
Okay, so here it's checking if it can go right, and it does. It can,
Good.
then it will move forward. Cool, now what?
And then it can't rotate right, so it's going to rotate left and move forward. And then up here, it can't do either, so it's just going to move forward. And so the first statement or the first direction is right, so it's going to rotate right. And at that point, it can't rotate left, and then it'll go into the white box.
Yeah, it's gonna check if it can move right first. And since it can, it's gonna rotate right, and then it will move forward. And then it can't rotate or move forward, so it's just gonna end in the wrong box. And all of this boiled down to, did you notice that it needs to go right first, then left? And the fact that it's checking the right side first led grid 2 into the wrong place. So the answer was A, grid 1 only. And that is the lowdown on control flow for the AP exam. Thank you guys for being here. Have a wonderful evening.
Bye.
Bye. You're welcome. Bye. May the 4th be with you too, Nelson.